So this question says the insurance company insures 4,000 people against loss of both eyes in a car accident, right? And from their previous data, the people who get this kind of accident is like this: 10 persons in 1 lakh. It means you could see what is the probability that a person will met with an accident is 10 out of 1 lakh. That's what. So let us write it. Probability that a person met with an accident, that's equal to, so let me denote that as P, that is P equal to 10 out of 1 lakh. Okay, so that's what 1 by 10,000. So this is what the probability that a person will met with an accident which causes this kind of injury. Okay, so what is the question here? What is the probability that more than 3 of the insured will collect their policies in a given year? Now you can take this way. You are actually performing a trial on 4,000 people. Now your aim is to see whether he met with an accident or not. If he met with an accident and if it causes this kind of injury, then he'll claim the policy. Otherwise he won't claim the policy. The policy, right? So now we'd like to see what is the probability that more than 3 of the insured will collect their policies. So now you define your random variable x. So x is the random variable which represents number of claims. And the question is, what is the probability that x is greater than or equal to 3? That's what they're asking. Probability that more than 3 of the insureds will collect on their policies in a given year. If they say strictly more than, then you can say strictly greater than or equal to. Now you should understand what distribution x follows. Can I say that x follows a binomial distribution with parameters 4,000 with probability 1 by 10,000? Can you observe that? Why? Because there are 4,000 people. Your aim is to see whether each guy, whether he met with an accident or not. If he met with an accident, you take it as a success. Otherwise, you take it as a failure. Okay. So you're simply looking at, when you perform 4,000 trials, you're looking at the number of success. That's what number of claims. Okay. So it is clear that this random variable x follows binomial distribution with these parameters, where you could see n equal to 4,000 and p equal to 1 by 10,000. And you can see that p is very small and n is very large. So in this case, what shall we do? So we take the Poisson distribution. So we say that x follows Poisson distribution with parameter lambda. And what is lambda here? Lambda is nothing but n into p. So that is what 4,000 divided by 10,000. So that's what you will get 4 by 10, which is 0.4. Okay, so this is what your lambda. Therefore, you can say that x follows Poisson distribution with parameter lambda. Lambda is equal to 0.4. So this is what you observe. Now it is easy to calculate probability that x strictly greater than 3. So which is nothing but 1 minus probability that x less than or equal to 3. Because it is difficult to calculate the other way. Since less than 3 there are very less number, so we should go in this way. Now this is same as probability that x equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2 plus probability that x equal to 3. Okay. And you know what is the probability mass function of a Poisson distribution? What is it? So let me write it here. For a Poisson distribution, you know probability that x is equal to I is nothing but e power minus lambda into lambda power I by I factorial. So let us write these things here. So this is exactly 1 minus of lambda, which is 0.4 power 0, lambda power I, into e power minus lambda, that is e power minus 0.4 by 0 factorial. 0 factorial is anyway 1, plus, and here e power minus 0.4 into 0.4 whole power 1 by 1 factorial. So plus that's it. So this is what you need to calculate.